Coulomb's law. Coulomb's law states that when you have two charges, negative and positive, or positive or positive, whatever, it's either it's positive, positive, negative, negative, or negative, positive. So it's trying to say that F, the force, is directly proportional to the charge 1 and charge 2. So if this is charge 1 and this is also charge 2, and also that same force is inversely proportional to the square of the distance, that is the distance between these two charges, the distance between them, let's call it r. So what it's trying to say is that the farther two charges are together, then the lesser the force between them. Or let me put it this way: if you have two charges that are placed, let's say for example you have two charges that are placed at 2 centimeters from each other, and you have another charge that are placed 4 centimeters to each other. Now the force of the one of the 2 centimeters will be more stronger than the one of the distance of 4 centimeters. So that is why it says that F, the force, is inversely proportional to the distance, and the force is directly proportional to the charge. So which means that as the greater the force, or the greater the charge, the attractive force, the repulsive force, the greater the charge, then the greater the force between them. But when it comes to their distance, as you move those two charges farther from each other, then the force reduces. But as you bring those charges close to each other, reducing the distance, then the force increases. So mathematically we say that our F is equal to K Q1 Q2 over R squared. That is, we actually remove the proportionality constant using this electrical constant, and K is given as 1 over 4 pi epsilon naught epsilon R. Let's begin to define all of these things one after the other. So our F is the force, of whether it can be force of attraction. So the F is the force of attraction or repulsion between the two charges. So don't forget that the charges can either be, the force between the two charges can either be attractive or repulsive. So, and it's measured in Newton. So the F is force in Newton, that is N. Then we have our Q, which is the charge in, this one is in coulombs, and is measured in C. We have our R. Our R is the distance, which is measured in meter. Then we have our E naught, that is called the permittivity of free space. Permittivity of free space. And that is, and is a constant. Is given as 8.85 times 10 raised to the power of minus 12 farad meter. Then we have the ER, that is the relative permittivity. Okay, so now I want to explain something. So the relative permittivity depends on the medium. Here we assume that the relative permittivity is in air. So, and the relative permittivity of air is 1. So F is equal to, that is Q1 Q2 over 4 pi R square. So now if ER is in air, and that is what is given as 1, so our F will be equal to Q1 Q2 over 4 pi E R square. So this is the formula for calculating electrical force of an electric charge. So this is the formula for calculating the force of an electric charge. So we meant to understand that the Q is the charge 1, the Q2 is the charge 2, then the E naught is the permittivity of free space, which is 8.85 times 10 raised to the power minus 12, and R is distance, is the square of distance between the two charges. So that is all for today. So in the next video we are going to be looking at some work examples on electric charge. Thanks for watching.